Okay, for number 59, I'm going to go to the whiteboard. I think a little more room to do this one. And let me go to the whiteboard. All right, so what are we given over here? In 59, we're given, this is number 59, by the way. Get my pen back. And 59, we're asked to integrate this function s. And again, if you can't remember what this is, that's fine. You just look back over the notes. Let me remind you, we've seen it before. All right, what have we seen before? We've seen this over here. So we've seen sine of x squared dx was equal to root pi over 2 s, this is where we saw it, and then it can be root of 2 over pi and of x, let me just close that out a little bit, x, try to be neat as possible, plus some constant of integration. So we saw that before. So what I'd like to do is differentiate both sides of this, all right? And so there's almost why you're doing that, just to see if I can get some kind of like integration by parts in the problem. So I'm going to differentiate this thing. I'm going to differentiate both sides. And that's going to be, let's see, d dx, d dx. Let's write that down. You're going to get sine. And then you're going to get what? Let's take a look at that. You're going to get, I'll simplify this too as I write things down. I'll have to simplify. You're going to get s prime oh, I'm sorry, that's s prime. Sorry about that. Put a prime over here. That's a prime. It's kind of hard. My penmanship's not great, by the way. And then it's going to be times the derivative of the inside of that, which is going to be root 2 over pi. So let me write this over here. Sine of x squared is equal to, well, it's just going to be that s prime all right, so that's not so bad. And let me just, carefully look at what I've written down over here. That sine of x squared is equal to s prime, this with respect to x, by the way, of that argument, which is the square root of 2 over pi times x. So now what I'm going to do is I make an integration by parts. Integration by parts. And I am going to say u is equal to, but it's going to look a little different than this one over here. Don't worry, we'll get back to that. That u is equal to the s function of this thing over here. All right, so I'll write that down. And then I'm going to write down, and again, we're trying to integrate something. I'll tell you what we're trying to integrate. We're trying to integrate this guy. We'll get back to the other one later. And we're trying to integrate this thing over here. All right, that's what we're trying to integrate. And let's take a look at that. So I'll write down, if that's u, I'll write down du. That would be s prime. And then times that. All right. And then I can put du down. I'm sorry, dv. What am I saying? dv equals dx. And that means v equals x. So let me, kind of move forward. And we're doing s of this. I'm going to put uv down now. And that's going to be x times s, and I'm just copying at this point, minus the v du. Right, v du. You know what? I forgot to do something here. That's the prime. So write that down. So what are you going to get over there? S prime wow, that looks really complicated, doesn't it? My question is, do I know what this is? Let me go backwards on that. Let's go back up here. And just this guy. So I got to rewrite it as x Let's see if I did that right. Yeah, I did it right. I made a u substitution now. And I'm going to say u is equal to x squared. That means du is 2x dx. Let's write that down. X, S, oh, you know what? I forgot something. I just noticed it too. And I got to get my eraser out and put it in there. All right, let me write this down now. So you're going to get, and I'm going to put a little star here. But my integration symbol looks like an S, but anyway, it's not. It's an integration symbol. So it's going to be sine of u. So I took care of this, I took care of this. X dx is 1/2 of a du. Let me keep moving. X, S, minus 1/2. The antiderivative of sine is going to be minus cosine. I just changed the sign of that. What's the u, though, going to be? It's x squared plus some constant of integration. And what's this over here? I'll write down what it is. It's this one over here. All right, I got a problem here. And so I don't know what the problem is. The problem is they didn't ask me to do that one. They asked me to do something a little bit differently. Right, so at least I got something written down here. And I'm going to simplify a little bit more, though. I write this as x, s. Don't feel obligated to do this, though, by the way. I like to look at this thing, and I notice that this thing over here can be simplified somewhat. All right? So it's going to be, let's see if I simplify that. That's going to be plus, whoops, I did it again. Plus 1 over the root of 2 pi. And then it's going to be cosine x squared plus c. All right? So I have to go back and really do another one. And the one I want to get to is I want to get this thing to be just a single letter. So I make a substitution now. Let's see if I can do it. So I'm going to say u is equal to this. I'm going to write that down for you. That's an integration symbol. S of u. Well, I think I got to write down du, right? What's du going to be? This. So du is going to be root pi over root 2 du. Let's go to the other side, see if I can do that. And I'm going to get, well, x, oh boy, I got to do that now, right? So let's look at this one over here and write this down. So it's going to be root pi over root 2 u is equal to x. Let me write that down. I'm going to write it this way over here, though. U. If you wonder what I'm doing, I'm making a substitution here. Times S of u plus Kind of complicated, isn't it? And the cosine of x squared, well, let's write that down. It's going to be cosine, if I were to square the x, I'd get pi over 2x. I'm sorry, I made a mistake there. Got to erase, not x. I'm squaring the x, so it would be pi over 2 u squared. I can say some constant. Doesn't matter what I call it at this point. There's some constant lying around. Constants could be changing over here. So I'm going to write this down now. So I'm going to go that this integration, I do it again. For penmanship, the integration s of u du. I'm going to multiply both sides by root 2 over pi. Now I'll write that down for you. Root 2 over root pi times, let's write this down over pi over 2, s of u, plus root 2 over root pi times cosine pi over 2 u squared over 2 pi, the root of it, plus c. By the way, see, I'm multiplying it again, but again, it's just, I'm not going to do these star things anymore in this one over here. A little complicated. So let me see if I can get this SU down now. Again, I get that integral symbol down. We'll look at the key in a moment. When I say look at the key, we'll look at the key. So what do you get over here? You just get SU plus. Well, let's see. The root 2's are going to disappear, and root pi times root pi is just pi. And then we get cosine pi over 2 u squared plus c. Now, by the way, someone says, you didn't want that one either. You're right. I wanted x. Well, this is going to be easy. Just let u be equal x now. Let's write this down, and then I'll put a box on it, and then we'll check it. And what I mean by check it, what I'm saying in my notes, by the way. We got to go back to that. All right. Again, I didn't do a lot of stars with the notation over there. And, you know, let's just go back to the actual notes now. And I want to make sure that I'm looking at, but before I look at the notes, I want to make sure I'm looking at something I can actually remember what I've written down. And I think I might have made a mistake somewhere. And I noticed it over here. I'll put this down here. I'll put this over here. Put the X there. I'm just kind of looking back over the work and just making sure I got everything accounted for. I think so. Now, can I remember this? Now, that's a problem with a computer. I'm not that adept at using an iPad. So what I'm going to do is I want to go back to the notes. And these are notes over here. Again, there's work over here. I'm kind of looking towards the end of it, though. I'm looking towards this thing over here. And by the way, it's much neater in this over here. I use star notations and stuff. But let me see if I can get my pen out again. And I'm looking at this guy over here. This was my goal, by the way. I got that part. Now, granted, when I wrote this thing down over here, I'll go back to it again. Yet I got the XS of x. I see that. And then I got the cosine, let's see, pi over 2 x squared. I do see that. I noticed when I wrote this down, though, I wrote down, let me just go for that. I wrote down the pi over here. What are they doing? They're putting the pi on the outside. It really doesn't much matter. It's the same thing. And I'm good to go. This is fine. So this is good. All right? Now, granted, someone says, I want to do it differently. We're going to encourage it. All right? That's what I did. That's what we initially see the things. But you might say, no, I see them differently. And that's fine. Right? You can see things differently. But the bottom line at the very end of it, when the dust settles, it should be an equivalent statement. What's the equivalent statement over here? We're really looking forward to seeing something like this in the end. All right, something readable. Thank you.